Nirvan, and our student presenter for the vote of thanks, Ms. Rashika Sharma. To formally inaugurate today's session, it's my honor to invite our Honorable Vice Chancellor, Professor Dr. Harish Shah, to deliver the welcome and opening remarks. Sir, please.
Uh, Good afternoon, everyone. Uh, am I audible? I just want to confirm that. Am I audible?
Yes, sir. Loud and clear.
Okay,
Yes, sir.
fine. So, good afternoon, everyone. It gives me immense pleasure to welcome you all to the inaugural session of the BioConnect webinar series, an exciting and innovative initiative by the Center for Scientific Research and Development, a constant unit of People's University. This webinar series envisioned as a for students, by students, of the students of CSRD platform is a remarkable step forward in empowering young minds and nurturing the next generation of biotechnology leaders. I would like to take a moment to commend Professor Dr. Subhash Khore, Head of Scientific Research Development and Student Advisor for this initiative and for his guidance and leadership in bringing this idea to life. This new initiative reflects the spirit of academic innovation and student-centered learning that we strongly uphold at People's University. The BioConnect series not only creates a space for knowledge exchange, but also instills confidence, critical thinking, and a sense of ownership among our students, qualities essential for tomorrow's scientific trailblazers. We are honored to begin this journey with an enlightening talk by a highly respected figure in the field of biotechnology, Dr. C.K. John, who is a principal scientist retired from Center of Scientific Industrial Research, National Chemical Laboratory, India. Dr. John will be speaking on a very timely and transformative topic, biotechnological approaches to increase saffron production through high-density greenhouse cultivation outside the crop native range. As you all are aware, Pompo is a place in Kashmir where maximum farming is done, saffron farming. This session promises valuable insight into how cutting-edge biotechnology can help us address real-world agricultural challenges and open new avenues for sustainable farming and commercial cultivation. I also extend my warmest welcome to all the participants joining us today, our students, faculty members, researchers, and biotechnology enthusiasts from across the country and beyond. Your presence here underscores the relevance and importance of such academic platforms in building an inclusive, innovative, and informed scientific community. I encourage you to participate actively, ask questions, and take full advantage of the opportunity to engage with experts and peers. With these words, I officially declare the BioConnect webinar series open, and I look forward to many more sessions filled with dialogue, discovery, and inspiration. Thank you, and I wish you all a great immersive learning experience and a productive and insightful session ahead. Now I will hand it over to our MC, Ms. Preeti. So, Ms. Preeti, over to you now to take forward the proceedings. Thank you.
Thank you so much, sir, for your inspiring work and for always supporting student initiative at People's University. Now, I invite Chairman of the Organizing Committee, Mr. Rishi Nirvan, to say a few words. Over to you, Rishi.
Thank you, Preeti. Good evening, everyone. I am Rishi Nirvan, chairperson of this student organizing committee, and I take immense pride in welcoming you all to the very first session of BioConnect webinar series, an initiative for students by students. started by the passionate minds of the Center for Scientific Research and Development, People's University. This is not just a webinar, but a moment, a platform where ideas spark, leaders emerge, and collaboration thrives. The BioConnect webinar series was born from one belief that students are not just the future, we are also the force of the present. And through this series, we aim to teach and practice what can't always be learned from textbooks. How to lead, how to manage, how to work in a team, and how to communicate with impact. Because science doesn't grow in isolation, it grows in conversation, cooperation, and curiosity. Today, as we launch this journey, remember, we are not learning biology, we are learning how to become leaders in biology, how to organize, execute, and inspire, how to handle real world challenges with the mindset of a problem solver and the heart of a team player. With that, I also would like to extend my heartfelt thanks to the Center for Scientific Research and Development, People's University, for providing this stage for students to shine and shiver. With that, I welcome you once again to the BioConnect webinar series for students by students. Thank you. Over to you, Preeti.
Thank you so much, Mr. Rishi, for your welcoming words. To take this session forward, now I hand over the virtual mic to our moderator, Ms. Akanksha Lodi. Over to you, Akanksha.
Thank you, Preeti. Good evening, everyone, to the inaugural session of this webinar. It's a truly special moment for me to be a part of this enriching session. As a student of biotechnology, being able to interact with a senior scientist like Dr. C.K. John is both an honor and a learning experience in itself. With utmost respect and great excitement, we are truly privileged to welcome Dr. C.K. John, former Principal Scientist, Division of Biochemical Sciences at CSIR, National Chemical Laboratory, Pune, India. Dr. C.K. John completed his MSc, MPhil, and PhD from the Department of Botany, Savitribai Phule University, Pune. Initially, he taught botany at Fergusson College, Pune. In 1990, he joined CSIR National Chemical Laboratory, Pune, where he was involved in research on forest trees, plantation crops, medicinal crops, and spices. Dr. John's research interest involves basic studies, applied aspects, having industrial application, and developing technologies which have societal relevance. Dr. John is a highly respected name in the field of plant biotechnology and tissue culture, and his work has significantly contributed to advancing agricultural science in India and beyond. His research focuses on in vitro propagation of economically important plants, in vitro flowering, genetic enhancement through polyploidy, and the development of abiotic stress-tolerant plant varieties. His research has not only pushed scientific boundaries but also brought real-world applications to the life, especially in context of cultivating high-value crops like saffron outside their traditional zones. So, as we all know, today we'll get to know about biotechnological approach to increase saffron production through high density greenhouse cultivation outside the crop's native range by Dr. John. Sir, it's a great privilege for us to have you here. With great pleasure, now I invite you here to deliver your talk. Dr. C.K. John, over to you.
Thank you, Professor Harish Rao, the Honorable Vice Chancellor of People University, Bhopal, and Dr. Subhash Ware, uh, Head Center for Scientific Research and Development, and all student organizers. Uh, I am really honored to be a part of this uh, webinar series, BioConnect, and when Subhash Bore told me about this initiative, I I felt that as usual, Subhash is up to something which is unique, where he wants the students to learn not only biotechnology but also how to organize uh, events and manage on their own, and also learn from experts uh, about the research happening in which has relevance to the society. So in CSR and CL, when I so initially I was working mostly on topics which are relevant, mostly which is resulting into publications. But later on, I thought that we should do something which has relevance to the society as well. So in 2000, I thought of working on Saffron. So now it is 2025. So last many years I have continued this research, and what I will be presenting is my work over a period, very long period of time, and so now I will start with my presentation.
Sir, do you need any help?
Just I'm okay. Yeah, yeah,
Yeah. It's feasible, sir. Just put
yeah.
it
It is
on
visible.
presentation.
Yeah, yeah. Yes, yes,
Put
yes.
it on
So
presentation.
yeah, yeah.
Excellent.
Presentation. Now it is visible to all of you.
Yes, sir. Yes, sir. Go ahead.
So biotechnological approaches to increase saffron production. There are three biotechnological approaches I tried, and the high density greenhouse cultivation of saf- the saffron outside the crop present range is one of them. So uh, saffron saffron is the right stigma of the Coccus sativus, is a member of Iridaceae, uh, is the most costly spice in the world. In 2 to 2.5 lakh per kg in wholesale, and 300 to 600 rupees per gram in retail. Uh, Saffron has three uh, compounds, phytochemicals, and one coloring matter which is crocin, uh, bitter principle that is picocrocin, and an odorous compound that is saffrona. And there are many other compounds also, but these are the main three ingredients, which has also great medicinal use. Saffron is used as a spice, coloring agent, and medicine. And recent years, there are so many medicinal applications of and great interest in saffron as a medicine. High cost of saffron is because of three reasons. One is uh, requirement of specific agrochromatic requirement for its growth, and low yield and labor intensive uh, harvesting. Increasing saffron production and export has great potential for the Indian economy, but by traditional cultivation in field, it is not possible. Saffron coccus, it is an autumn flowering perennial plant, sterile triploid, and it is propagated through underground combs. Needs cold, chilling winter, hot, dry summers, and autumn climate for flowering. Needs strong direct sunlight for its growth, and it requires about 600 to 700 millimeters of rainfall annually. But saffron grows also in places where rainfall is little more or less. Flowering takes place in late October or early or middle November. Flowers are fragrant and have it has six stigmas and six stamens, and the the produce of economic importance is its stigma, and there are three uh, purple stigmas in the flower, and which is collected, dried, and the spice is produced. So saffron cultivation dates back to about 1500 to 2000 BC and originated possibly in Asia Minor, Greece or Greece, and at present it is cultivated in a narrow geographical belt uh, starting from Crete in Spain in the west and Kashmir in India in the east. There is a there is a dogmatic belief that saffron can be cultivated only in this narrow belt in its native range, and it is impossible to grow saffron outside this range. And our attempt has been uh, to grow saffron outside its native range. So we have tried three biotechnological approaches. So the saffron was introduced in Kashmir, and there are many beliefs about the origin of saffron in Kashmir. It is believed that it was brought to India about in fire around 500 BC, and as per Chinese historian, it is believed that a Buddhist uh, missionary named Madhyamika first introduced saffron in Kashmir in 5th century AD, and other sources suggest that Polynesians introduced saffron in Kashmir, and they were trading saffron, marketing saffron throughout the world, which is produced in Kashmir. And local Kashmiri mythological tales uh, attribute the introduction of saffron to Kashmir to two uh, Sufi saints. And uh, according to according from all this account, it is clear that saffron is not a native crop of Kashmir, but it was introduced from somewhere. So it also shows that saffron can be introduced in other locations because in whether it is 2000 years back or 1500 years back, when it was introduced in saffron, there was no technology available for modifying the climate conditions or soil conditions. There was no knowledge of agronomy or as it exists now. So what happens now is that we may be able to introduce in some locations where the climate is not exactly suitable, but some aspects can be modified, and we can cultivate saffron and introduce in new locations. Biotechnology approaches to saffron production, as I told you earlier, we tried three biotechnology approaches. The first one was initially what I thought was we will develop a technology for in vitro production of flower or in vitro proliferation of floral primordia through appropriate use of cytokinins or other plant growth regulators by tissue culture. So this experiment was conducted and we got success after a very long time, and we have filed a patent on this. And the second approach was to develop a variety which is suitable for growth in uh, wide ecological niches other than the, the, the natural range by selection or by uh, some biotechnological techniques. And uh, means this approach was also we have tried for some time, but it was not successful. And the third approach was the high density greenhouse cultivation of saffron. And we have developed over this work, what I am presenting now is done over a very long period of time, 10, 15 years. And one by one, initially, the idea was to grow saffron in a greenhouse since it was my experimental plant. So when we found that it is difficult to grow saffron in Pune greenhouse, so I looked at finding out why it is not growing. And then we found that soil and climate are important. So this shows the annual growth cycle of saffron. In summer, means May, June, July, the the forms are dormant, and in by onset of the rainy season, the form sprouts. But since the forms remain about 4 or 5 inches below the soil, it takes maybe another 15 days or 3 to 4 weeks to come out of the soil surface, and it continues to grow, and the plant reaches a height of about 6 inches, and by end of October or by first second week of November, the flower comes because the flower buds are already present in the forms, and then the plant continues to grow. The leaves continue to grow to a length of about 1.5 feet, and during winter, the plant grows in winter. This is a winter growing plant and autumn flowering plant, and the growth is completed by early or mid summer. That is in Kashmir, where the plant grows, it is by middle of May. And then the plant produces many replacement forms, and uh, those forms go into dormancy. So what we have done is, as I told you that we found that the climate and soil are important. So the soil, the whatever soil available here, we tried different soil types, and we found that soil is not suitable. And so we thought of getting soil from Kashmir, analyzing the Kashmir, the soil from Kashmir saffron field into fine detail, and understand what is the peculiar about that soil. And we got the soil and got it analyzed. So this slide shows the soil analysis physical. So what is the, how much actually saffron needs uh, uh, that the soil which has uh, not waterlogging and which is calcareous soil. So the physical parameters you can see here that six different type of soils. The first one is Kashmiri soil. The second one is the pointer soil, the riverbed soil here, and like that, different type of soil, lead laterite and this like that, all quite different soil types available here. We tried, and we tried growing saffron this different soil types, and also what we did was that we made after understanding the physical properties of the soil, we thought what type of soil will be suitable. And the next aspect is the soil analysis chemical. What is the nutritional components and what is the nutritional status of this soil from Kashmir separate field that was analyzed. And the next, this is also the biological, soil energy biological. We got the soil and isolated the mycorrhizal associates. Mycorrhizal associates are very important for the plant growth because the mycorrhizal associates, they colonize the root and help in the uptake of minerals from the soil and help in the healthy growth of plants. So we analyzed that, and this work was done with in collaboration with Professor Mahesh Borde of Botany Department, Savitribai Phule, Pune University. A greenhouse. Uh, Actually, initially we were using a normal greenhouse, and we found that, as you know, the normal greenhouse is a fan pad system, and the electric supply is very important that to run that fan pad system. And if the fan pad system doesn't work, what happens is that temperature goes high. So we found that there is some limitation of this traditional normal greenhouse because the plant needs cold in the winter. So the closed structure does not allow the cold to come in the greenhouse. So in winter, what happens is that in November, December, in Pune, outside temperature is about 9, 10, 12 degrees, but inside the greenhouse it remains some 5, 6 degrees above. And so we thought of custom designing a low-cost greenhouse uh, and allow the cold during winter to come in. And also we wanted that power failures should not spoil our experiments. The power failures, even for a short time, and especially in the afternoons, can spoil the experiment. And when we are conducting experiments on a plant like saffron, which is very sensitive to temperature variations. So we have custom designed a greenhouse, or an old house greenhouse modified, and we made a ventilation below and above, so that through the lower ventilation, the cold air can come inside, and the hot air can go outside through the ventilation above. And also the flooring was removed, and it was layered with bricks, and there was some porous brick wall was created made around, and that was kept moist. So what happened is, simply speaking, it was a mud cut technology we are using, and we wanted it to be as low cost as possible, so that it can be replicated in rural areas where the people can make the greenhouse and with the locally available material at the minimum cost. Next is irrigation. Irrigation, the plant, initially when we plant growing the saffron plant in pots in the locally available soil, what we found was that we were irrigating with normal water, which is usually at 10, 20, 25 degrees centigrade. And plants used to grow up to December, possibly up to middle of January, and then die. And the leaves used to become pale green, or then it used to become yellow and die. So then, like we realized that if you irrigate with ice cold water, the plants grow for longer and the leaves are more green and healthy. So this is done by extracting and analyzing the chlorophyll content. So what happened is we thought that now the plant needs irrigation with ice cold water. So we the next year when we are growing, we used to irrigate the plant with ice cold water, mimicking the snowfall during winter, means second half of November, December, January, like that. Plants continued to grow healthy, and they were producing crops, but they were not big enough in the sense that the 1, 2 gram, 3 gram, and then the plants used to die maybe by end of January or by middle of February, like that. So irrigation is very important, and then we devised the low cost underground drip irrigation with ice. So what we did is uh, once this is this two parameters like soil, and we designed a custom designed planting medium which is sufficiently porous and having the pH and other nutritional requirements as per the Kashmir soil, and we made a two-layer system. The lower layer is that the planting medium, and on that we have planted the corms, and upper layer was soil. So the upper layer was acting only as a blanket, insulating the plant, the corms and the roots uh, from the cold in the winter. Means usually if, the snow falls directly onto the corms or the corm is the actual stem of the plant. So there can be frostbite and frost damage. And secondly, in the summer, that is to protect the plants from the heat. So the upper means when the corms are remaining about 4, 5 inches below the surface of the soil, the purpose of this upper layer is only to protect the plant from the frostbite or heat damage during summer. So we procured saffron corn from Kashmir and planted them in pots, and for drip irrigation, underground drip irrigation, we devised the low-cost method. We have kept three thermocol cups in every pot, and these cups had holes at the base, and we put pebbles in them, and in the night we put ice into these cups, because initially when we are putting ice into the wall pot, it was requiring a lot of ice, and since the ice used to be collected from ice breaking machine, that much of ice every day getting was difficult. So we wanted to minimize the use of ice, and also the give the ice cold water directly to the root, because upper a layer of 4 or 5 inches is only a blanket, because the plant actually the comb and the roots were below that. So there was no need to irrigate the upper layer. So we have given water directly to the root, and the we standardize many parameters. One is the time of comb lifting, when the comb should be lifted from the separate field, and so we collected a different season like June, July, August, September, like that, and when they have to be planted. Actually, we have planted also staggered planting at different times in the first week of September, and middle of September, first week of October, and also first week of November, to get an idea that different planting type, how it affects, and also the like irrigation, fertigation, and all other parameters were studied. And I'm not giving all the details, because if I have to give all the details, it will be too long. So now, in 2016, means after many years of experiments and experimentation and learning, and putting all those, the data collected together to uh, make inferences as to how we can get perfect flowering, perfect growth. So in 2016 November, we got flowering like in Kashmir field. So this shows the greenhouse. So you can also see the wall where that, as I told you, the lower ventilation where the brick forest wall is made. By keeping it moist, we lower the temperature. And also the middle photo shows the a close-up of flowering, and right side you see one flower. So the stick corolla, and the stamens, and the three bright red stigmas, which is the spice, uh, the product of uh, economic use after drying that. So the lower right side lower photo shows the saffron collected, harvested from the greenhouse, uh, the fresh saffron stigmas. So this is a video. So you can see that like so flowering was synchronized, and you see that in each pot we had about 15 to 17 combs planted. So in the middle it was big combs, and towards the uh, periphery, not the outer periphery, but in the middle, there was medium comps, and to uh, the extreme periphery, it was small comps. So this planting was done in this way to understand the size of the comb, effective size of the comb, and how many flowers are produced, and of the total number of combs planted, how many flowered, and things like that. So one very critical observation was that the combs planted, staggered plantation was done in first week of September, middle of September, and first week of October. All those plants flowered synchronously in the fourth week of November. So there was some first flowering in the third week. We started, and initially it started with two flowers, and then suddenly, and I actually remember in 22nd, 23rd of November 2016, all this flowering happened. So this video I have showed you as taken sometime on 23rd of November 2016 in our greenhouse. So, and afterwards there was some first flowering in the last end of November and first week of December, like that. And then all the got completed. Then plants started growing vegetatively. So this slide shows the saffron collected from flowering in ancient greenhouse, and also the dried saffron of commerce is what the dried saffron which is we get in the market, which is produced by drying the freshly harvested saffron stigma from the greenhouse flowering. And this was done by drying in the sun for 3 days. But usually the drying can be done in different ways. One is that we tried many different methods, and in Spain nowadays the practice is that the saffron is dried for 1 minute at 100 degrees centigrade. Somewhere it is dried for a week in a closed room, uh, and some places it is dried at 70 degrees for a few hours, like that. So anyway, there are different methods, and they have the dry method also has some effect on the preservation of the active ingredients, crocin, pycrocin, and saffronan. So this shows the continued growth of saffron. So as you can see that that the pots, in each pot there are three thermocol cups in which we have put ice, and the ice melted and percolated down to the root zone and irrigated the plant, and giving an idea that plants, there is a snowfall, and then now it is being irrigated by the melted snow, like that. The plants continue to grow, and even with this, uh, in Pune, because of the peculiar climate in Pune, the plants survived only till middle or end of March. They did not grow in April, May. And since the plant did not grow to its full, that vegetative growth phase, possibly only less starch is produced, and that has resulted in production of uh, forms of about medium size, 5 to 8 grams. But in Pune, our experiments in the greenhouse, we could not produce the forms of uh, 10 to 20 grams, which is required for continued, because the next season those crops can be planted and we can continue the production here. But it is not possible because I was simply conducting experiments to understand whether the saffron can be planted grown outside the crop's native range, and so it can be grown. But only thing is that for commercial cultivation, commercial production, cost-effective production, growing saffron in and producing the replacement forms which can flower in the next season is important, because there is also a form multiplication. When you are planting one form, the next year 4 5 forms are produced, out of which some 3 2 3 are of big size. So in the first year after the planting, if you are getting a certain amount of saffron, but the next year it may be doubled or become 3 times. So in the first year, if you are getting a produce of 1 kg, the second year it can be 2 kg or 3 kg. The following year it can increase, and then it is continued for up to 5 6 years, and then it declines because compacting. So then it is time for replanting. So this is the way it is grown in Kashmir field, and so producing big comps was very important for uh, successful high density greenhouse cultivation, which is not possible in Pune, but it may be possible in some places where the cool deficit is not very uh, high as compared to its native range. So now this slide shows the climate details. So the rainfall and the temperature maximum minimum in the right side. So this is a climate details of Pampur. So as you can see that summer summer is somewhere in May, June, July, and you have rainfall in January, February, March, all the uh, 12 months. And during June, July, August, the rainfall is very less. And after summer, there is a sudden fall in the temperature, and also significant reduction in the day length also, because as we know that Uttarayan and Dashinayan, as the sun moves towards the south pole, from the sun moves to the north, the day length is increased, and when sun moves to the south pole, the day length is increased, the night length is decreased, and day length is decreased. And similarly, there is a difference in temperature also. Summer is when the sun is in the north pole, north hemisphere. So anyway, so this shows that how this climate in Kashmir is distinct in Pampore, and in December the minimum temperature goes to almost zero and goes to -1 to 3. And in January, February, you can see that that minimum temperature, that is night temperature, that usually it is measured in, I think, at morning at 4 o'clock, and the night temperature is sub-zero. It is not very -5, -10. It is not like that. It is -2, 3, 4, like that. So that results in snowfall, and that snow melts in the day, and the molten snow, the ice, uh, is in, irrigates the plant. So the plant senses the irrigating water temperature and get an idea about the, the climate, the season, and so when to flower, when to grow, and when to die. All this, the plant gets through the temperature. The temperature. That is why the temperature is very important. So in Kashmir, Jammu Kashmir, in Kashmir, Pampur, and in Jammu region, there is a small area where about 200 or hectare or some small area saffron is grown, and it is a center of protection where this is uh, the temperature details of Kishtwar in Jammu region. So this shows the climate details of Pune. So now in this you see the temperature always remain about 10 degrees or like that. In some locations, the temperature can go up to uh, 8, 9 degrees also. And winter is summer is early. Summer is March, April, May, and then because of rainy season, there is a fall in temperature, and then after the rainy season is over, the temperature instead of coming down, it goes up, and this confuses the plant. Whether it's of like in earlier slide which I have shown in the saffron growing regions, how the temperature is, how the climate is. Here the temperature goes up during October, and then because of winter there is a fall, and actually the temperature doesn't go below 8 9 degrees in the night also. So here that the saffron normally does not grow, and but in the greenhouse we have conducted the experiment. And another detail about the climate is there is in January, February and all there are no rains, but maximum rain happen in June, July. In July, month of July, August, and partly in September there are rainfall. And this one factor is not suitable because this is a time when the crops are in dormancy, and when the crops are exposed in field cultivation, or when the crops are exposed to such heavy rainfall, the plants usually the crops they decay, and in such location in open field cultivation is not possible, and also uh, the temperature always remains, and the temperature deficit as compared to the native range of saffron is very high. Saffron cultivation requires suitable soil and climate, fertile, well-drained loamy soil, or a mixture. We can formulate planting medium, and we have formulated, and that we have grown. And there are 4 climate requirements. That the flowering requires autumn-like climate where the night temperatures are about 10-12 degrees, and day temperature can be about 17-20 degrees. And in the winter, the the night temperature has to be very cool. And in the summer, the temperature can be about 30, and even higher temperature of 40 also is no problem because that can be managed by adjusting the planting depth, how deep the crops are planted. Instead of 4 inches, it can be planted 5 inches also. And this map of India shows some location where saffron can be introduced. So whatever is in blue, that areas like Jammu, Kashmir, Leh, and Himachal Pradesh, Uttarakhand, maybe in uh, Arunachal Pradesh, there are some locations that these locations need to be identified very carefully, and all aspects of that particular location, and also the soil in that location. Sometimes the climate may be suitable, but the soil may not be suitable, and the location may have a clay soil or some poor soil which is not suitable for the plant's growth. So the location may have to be identified very, very carefully, taking into consideration both the climate and also the soil. And the soil is not that critical as climate, but it can be modified. We can use part of the local soil and also add some additive, maybe the fine sand to increase the porosity, or some that soil conditioners to increase uh, the nutrient content and things like that, or water holding capacity and things like that. And in this slide also, you can see some locations in the peninsular India, where somewhere you see that somewhere in near Rajasthan, there is one that is Mount Abu, and some locations here in south also, that Munnar, that Uti, Nilgiri, Kodaikanal, and some locations, because of high altitude they show cold climate. And I have done some trial. Details are not given, and I'm not giving the more details here. But I have done a very small trials in that locations to understand. But these locations are not suitable. It is not possible to grow separate there for one reason, that the winter is very short. Maybe in Munnar, the temperature may go down to 0 degree, or maybe little ice may fall also, but that is only in the last week of December, first week of November, first week of January, and only for a very short time that fall in temperature happens. Then it increases. So that short winter is not sufficient for this plant. It may need a long winter. Now, the what are the major challenges of greenhouse high density greenhouse cultivation of saffron? And the the biggest challenge is producing bigger combs of about 10 to 20 grams, which contain the flower buds in the location where we are introducing the crop. And for this, the plant needs to grow till end of April, middle of May, and sufficient starch photosynthesis should happen. It has to be grown in with bright sunlight, and uh, the sufficient starch has to be produced by the leaves and translocated down to the combs and stored to produce bigger combs. So this is not possible in many locations, and this is not possible when sufficient quantity of nutrient-rich planting medium is not used. And when the the uh, inoculum inoculating with the appropriate microsource associates are also required, and it needs many parameters to be standardized and put together to have this plants growing sufficiently long and complete the life cycle, produce sufficient stars, and produce sufficient number, very good number of replacement combs. Many of them are in big size and which can further continue, and in further month of June, July, the flower buds will be produced and they can flower in the next season. So this is the major challenge. So now what next? So what need to be done? So I've shown you the work which I have done by the working in CSRD in Pune, and this work was done during 2012 to 17, and then I continued till uh, one 1 year more the same experiments, and also uh, some small experiments were conducted further, and so here what is required is making a prototype of a greenhouse, a low-cost greenhouse, and this may have to be done, uh, may have to be a custom made for each location. So it may be a different climate factor uh, in one location, and it may be another climate factor in another location. So the standard uniform greenhouse may not be suitable for all locations, but it may have to be understand the climate, and then as per requirement, it may have to be modified. And it has to be sufficiently low cost to be prepared, made with the locally available material, so that it can be environment friendly, low cost, and so that keeping the cost is very low is very important. And if the cost is increased, that adds to the production cost, and then the saffron produced, the production cost itself will be more, so that it cannot be marketed in, it cannot compete with the, uh, you know, whatever you produce may not be cost effective, competitive. And then, like the local soil and making a suitable planting medium, formulating soil planting medium, and irrigation. The temperature has to be, the winter has to be sufficiently long, November, December, January, February, March, where the temperature has to be less than, 4 degrees. And night temperature has to be less than 4 degrees. And whether there is snowfall or not, that doesn't matter. But the night temperature has to be uh, less than 4 degrees. It can be 2 to 5 degrees. And then that water, irrigation water has to be available. And then this water, ice cold water has to be used for the underground drip irrigation. And the underground drip irrigation has to be uh, standardized. And also, this water experiment may have to be scaled up, and maybe in some places it can be grown in raised beds and things like that. So this needs, identifying the suitable locations, and depending on the climate and soil factors, custom uh, standardizing the method for that particular location is required. Now, indoor subsistence farming. So nowadays there are in social media there are so many uh, videos on and in newspaper also. There are some there are reports of indoor subsistence farming in from many locations in India and abroad. So these are from anywhere, and this gives an impression that saffron is the most easy crop to grow by indoor farming by aeroponics. But from my experience my research experience of working on with saffron for such a long time, I think it is not possible. Saffron is one of the most difficult crop to grow, especially in the outside the crop's native range. And getting flowering, getting combs and keeping in trays vertically, and then in a closed chamber through chillers giving temperature of 12 degrees and 10, 12 degrees during October, November, and getting flowering is not very difficult. But continuing to grow those combs and producing big replacement combs, sufficient number of big replacement combs is the most difficult part of this whole exercise. And this makes this indoor farming not very, cost effective. And secondly, uh, usually the people are growing it 100 to 100 square feet of grow chambers, insulated grow chambers. And so what happens is that if you are using 500 kg of combs, so the next slide will show the the economics. So the infrastructure, setting up the chamber may cost from 5 to 10 lakhs, depending on the size, location, whether you have a room already or not. And secondly, the recurring cost, the cost of comps, that is about, I was told, that is about 800 to 1000 rupees per kg. So it can be about 4 to 5 lakhs for 500 kg. And then electricity charges, manpower. So electricity is 3 to 5,000 rupees per month. So it can be anything between 36,000 to 50,000 and for 1 year. And also the labor, that manpower. The manpower can be, if you are working, you're doing yours, the person who is doing this indoor farming is uh, working himself or herself, but still, when it is a business, we have to calculate the cost. It can be, say, 10,000, 15,000 per month if you calculate. It can be about 1.2 to 1.8 lakhs per year. So this is a recurring cost. So it comes to that about uh, 10 to 12 to 17 lakhs uh, rupees if you are spending. From this 500 kg comb, what you can produce is only about 150 to 250 grams. So the actual market cost of that can be 50,000 to 75,000 rupees. So by spending so much, you are producing only a very small quantity of saffron. So this is not cost effective. Secondly, if the infrastructure is the first year, the second year, again, if you are getting off from Kashmir, then again the cost remains, only the infrastructure cost is less, but other recurring cost has to be met. So it will be about 5 to 10 lakhs less. So maybe about spending about 10 lakhs, 5 lakhs, 5 to 10 lakhs, you are getting only produce uh, about 50,000 to 78,000 rupees of value. So this is the economics. I think roughly what from my experience I have calculated, and so it is not a cost-effective proposition. So now what happens is that the from whatever reports in newspaper and otherwise, what I understand is Kashmiri section is under threat. And the earlier, maybe in 1990s and all that, it is the statistics shows that we used to produce about 30 to 35,000 kilograms per annum. And now, in recent years, it has declined to about 4,000 to 5,000 kilograms per annum. But the latest available information is that in 2024, the production was only 2,800 kilograms. So the factors are declining area under the saffron cultivation, saffron crop, and reduced productivity. There is a it may possibly because of reduced soil fertility or climate change, or also it was told that there are some cement factories that the fly ash, all this add to the lowering of productivity. And also climate change. Climate change, as it happens everywhere, the climate change happening in the native growing area also is affecting the saffron production and over extraction. And one factor is that now people want to grow indoor growing and all that. There is demand for saffron corms, and farmers are over extracting and selling the corms, and this is resulting in the genetic, that depletion of this one, and uh, the saffron uh, throughout the world. Which you see that what is grown in Spain, Crete, Spain, is the mild variety, and what is grown in Iran is the intermediary, and what is grown in Kashmir is the best variety, and which has the more amount of active ingredients, which has more color, more the taste principle, and more the 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 flavor also, and the aroma also. And coming to the end, the future prospects of saffron is that saffron, very low volume and very high value agriculture produce, has a great potential for the economy. And there are ever increasing demand, the local, national, and also export market. By developing appropriate technology for saffron production and introducing into new locations uh, outside in Jammu, Kashmir or Leh, Himachal Pradesh, Uttarakhand, Uttaranchal, Arunachal Pradesh, etc. If we increase the production, there is a uh, great uh, potential for the farmers, the traders, and also for there is a potential for agro-tourism in these locations where there can be many economic activities through agro-tourism also. So this is something which can uh, greatly uh, help the nation and result in a great economic value. So with this, I am concluding my talk. Thank you very much. And uh,
Thank you, Dr. John, for that incredibly thought-provoking and inspiring talk. We'll now move into the Q&A session. We have already received some great questions through registration and live chat. If you haven't sent yours yet, feel free to drop it in the chat box. You are also welcome to unmute yourself and ask your questions directly. To get the things rolling, let me begin with a few questions that we have already received. So my first question from Dr. John is that are there any pest or disease challenges that arise when saffron is grown in greenhouse systems, and how are those managed biotechnologically?
actually, the saffron form, like form rot is a disease. So actually, when we receive the forms, while usually we used to receive it through, it used to be sent in a, as a parcel. So what happens is that when it is initially when it used to be sent in a closed this one, there used to be fungal infection things like that, or the cob, the planting material. So then I suggested to them that you send it in the after extracting because the combs remain underground when they are dormant in summer there, month of June, July. Initially, it used to be extracted and sent in the month of August. So I wanted to conduct experiment during, the time of comb lifting. We wanted to study so that it is to be collected in June, July, August, September, like that. So what happens is that I told them that you extract, keep it open so that some moisture can be lost and just to be cleaned and sent. So then we realized that there is no much disease or fungal infection or comb rot or things are there. And as soon as we receive, we used to remove all those infected combs. And then what we used to do is that we used to remove. There is a comb, there is a covering. It is to be removed and treated with, some fungicide and dried, and then it will be kept below the sterile sand before planting. So, but in the greenhouse, when we are planted, we have not seen any pest infestation or it was not requiring any any treatment. So mostly the infestation was of forms only, and since it was addressed and not to get the uh, disease uh, material, and as soon as it is received, they are destroyed, and then we are treated and controlled. We did not face much problem with any diseases as such.
And the next question from you is, Dr. John, as you know, that biotech often walks a tightrope between innovation and cost. So, what's your take on making high-tech saffron cultivation accessible to small and marginal farmers?
So, as I told you, that each and every step we are trying to uh, keep the cost less. So I wanted the greenhouse to be low cost. So I told you that the greenhouse which I have used for conducting the experiments in Pune, the chemical laboratory, was an old greenhouse which I modified. So there was no fan system. There was no need of electricity, and also there was no requirement for that simple uh, mudcut technology. So when it is a agro technology, we have to keep the cost low. And even for ice drip irrigation, underground drip irrigation, what I used was thermocol cups. When I wanted something like some device to give underground ice cold water directly to the root and reduce the quantity of ice required, someone told me that we can make a funnel type structure, and that was to cost about 500 rupees per one. So that will be per pot. It will be costing 500 to conduct the experiment. So I wanted to have something low cost. So I thought of how what can be done. So I got the idea of using these thermocol cups. So what I have done is that thermocol cup, that usually we use for taking tea and all that. So in some functions, it is available. So nowadays it is not available, and those days it was available. And now maybe possibly because some idea that thermocol cups are not available in the market, so it's only paper cups, maybe more environment friendly. So what I have done is that I made a square hole, 8 square holes. When we are putting pebbles, the pebble, if it is round, it goes and closes that hole. If it is a round hole, so I made a square hole so that even if a pebble comes and closes it, but by the side, what ice cold water can go down. So from 500 rupees for conducting experiment, I brought down the cost to 2 rupees 10 paisa because one thermal cup used to cost 70 paisa. 100 was 70 rupees. So 2 rupees 10 paisa per cup for conducting experiment. So the same philosophy may have to be continued further to develop the technology where the cost is always less, the production cost is less, so that the farmers, what they produce, can be priced competitively, or they can have a larger profit margin. You understand? What we are doing, biotechnology we are developing for helping the farmers, so that they can have a high value, low volume agriculture produce by simple, maybe drying for some time, some few days. Uh, there are now different drying methods. I told you that it can be dried for 1 minute at 100 degrees, and they say that that preserve most of the phytochemicals. So now, with minimum simple post-harvest processing, they have a produce which has a long shelf life, local, national, and international market. So this was the idea of selecting the crop. And while I was conducting the experiment, always I wanted it to be low cost. Understand? So this is necessary for biotechnologies to be successful, and especially in the agriculture biotechnology, when we have to transfer to the farmers. The idea is that the technology developed and given to the farmers, and thousands of farmers are growing in thousands of hectares and producing, and that puts money in their pocket. That gives job to the farm laborers, and that gives the produce to the traders. When it is traded, the GST, it goes to government. So there is something like, and if it results in agro tourism, lot of tourists go. There are other like hospitality, that hotel in business, they are all, so that in any place where a new such type of technology is introduced, a crop is introduced, can result in great economic benefit to a lot of people. You understand? So this was the philosophy on which I worked, and I feel this is a model actually. This is one example which can be replicated in many other technologies also.
This was really a very great idea, and this inspired us a lot, sir. This is the most asked question from everyone. How long does it take typically for a greenhouse saffron project to move from pilot to profitable?
See, when I started this work sometime into, I got the idea and of working on saffron. Initially, I was mostly a biotechnologist working in tissue culture, plant tissue culture area. So, in my profile, I have written that the forest trees, medicinal plants. I work for some time on bamboos and things like that. So that I got the idea of working on saffron. So uh, it required a long time, to put all this different aspects together. So since I was working in the uh, public funded lab, and this is one of the project I was working on. I was doing few other things also, but maybe it may not be very quick. And now, from whatever wherever I stopped, what is required is identifying some locations suitable for the growth, and whatever I have developed, 90% of the work I have completed, and that needs to be fine-tuned and introduced in all those locations in small, means maybe 100 square feet, 200 square feet, or 500 square feet small greenhouse. It has to be tested, proved 100%, and then it has to be transferred. It is required that we give technology which will work in the field to the farmers, so that they also develop a trust in the, like in biotechnologies. So otherwise, most farmers, if you see 100 farmers, 90% of them would like to grow what his father or grandfather was growing by the same method, and the process in the same way, things like that. When we are going, and we have to see the progressive farmer who is ready to think out the box and who is ready to experiment. So when someone is there in that field or that area who is ready to risk, their because these farmers are usually hand-to-mouth people, and they are dependent on the income from whatever they are growing for their survival. So what happens is, especially smallholder farmers who have got very small areas. So what happens is that when somebody is a progressive farmer, that mindset is very important, and we should make sure that what technology we give them is definitely works. And then what happens is that when someone has, taken initiative and we are given a technology, when other people see that it is working, then maybe 10, 20, and gradually more people will be interested by seeing that the technology is working and it is giving you profit, like that. This way only you can introduce the technology in the field. Understand? So if you want to introduce a new crop, you need some farmer who is ready to try that, and then we have to give them uh, really 100% foolproof technology.
Thank you, Dr. John, for patiently addressing all our questions and for sharing your deep insights into their fascinating area. Now, I pass it back to our MC, Miss Preeti.
Thank you, Akanksha. So, as we approach the end of today's inspiring session, now I invite Ms. Prashika Sharma to deliver a vote of thanks on the behalf of organizing committee. Over to you, Prashika.
Yeah.
A very warm good evening to everyone present over here. As we conclude this insightful and inspiring inaugural session of the BioConnect webinar series, I feel truly honored on behalf of the entire CSRD student team at People's University to extend the vote of thanks. We begin by expressing our sincere gratitude to our Honorable Vice Chancellor of People's University, Professor Dr. Harish Rao, for graciously inaugurating this initiative. Sir, your encouraging presence and motivating words have set the perfect tone for what we hope will be a transformative learning series. A special thank you to our esteemed speaker, Dr. C.K. John, for delivering a thought provoking session on biotechnological approaches to increase saffron production through high density greenhouse cultivation outside the crop's native range. Sir, your insights have not only expanded our academic horizon but have also sparked inspiration among us to explore practical innovation in biotechnology. Our sincere appreciation goes to our mentor and guide, Professor Dr. Subhash J. Bhore, head of CSRD. Sir, your constant support and belief in student led initiatives continues to drive our efforts forward. A heartfelt thank you as well to our moderator, Ms. Akansha Lodi, for smoothly conducting today's session and encouraging meaningful interaction throughout. We also acknowledge the dedication of our organizing committee chairman, Mr. Rishi Nirvan, the committee members, and the entire CSRD team for their hard work behind the scenes. Your commitment made this event a great success. And last but not least, big thank you to all our participants and attendees. Your active involvement gives purpose to this platform and motivates us to keep learning and growing together. This is just the beginning. The BioConnect webinar series is envisioned as a vibrant platform where ideas spark innovation, where students evolve into leaders, and where knowledge is transformed into purposeful action. We hope today's session was as enriching for you as it was for us, and we look forward to welcoming you all again in the upcoming chapters of the BioConnect webinar series with the motto for the students by the student. And before we conclude, we offer our heartfelt and special thanks to Honorable Chancellor of People's University, Shri Suresh and Vijay Varghya, and Honorable Trustee and Pro-Chancellor of People's University, Dr. Megha Vijay Varghya, for their constant encouragement, visionary leadership, and unwavering support that continues to shape the academic excellence of this institution. Their inspiring guidance remains the foundation of initiatives like this one. Until then, thank you once again for joining us today. May your journey ahead be filled with curiosity, inspiration, and meaningful learning. Wishing you all a wonderful evening. Now, I pass it back to our MC, Miss Preeti. Thank you.
Thank you, Prashika, for your heartfelt words. Thank you once again, everyone who joined us today, especially our speaker, our vice chancellor, our mentor, and all the participants. It was a great session today. Before ending this session, we would like to hear feedback from you all participants. The post-webinar survey link is posted in the chat box. We promise the evolution survey will not take more than 2 minutes. Your feedback will be greatly appreciated. We will wait for a few minutes to let the participant complete their feedback forms.
Sorry for interruption, sir. Dr. John, there is one question from our chairman, Mr. Rishi.
Yes, sir. Good evening, sir.
Good
This is
evening.
Rishi. I am the chairperson of this organizing committee,
Yeah.
and I have one question regarding the cultivation. That the major concern of the saffron that it is
Mm.
very expensive, and
Yeah.
as you mentioned that with the investment of to 12 to 17 lakhs, there is almost an output of only 70,000 rupees. So
Mm.
currently it was not efficient. But with time, with research, and with investment, as you said, that we are closing this gap, and we want to make this as efficient as possible. So, but the concern, sir.
Yeah. Now I understand your question. This is that what I have talked about the indoor farming is not my work. So
Yes,
it is
sir.
a spin of my work and it is happening from people. No one has
Yes, sir.
developed a technology end to end like that, but some people are giving the training and some persons, a lot of people have approached me also. And
So,
then who are doing that, they have approached me and asked me that later on they realized that this work was initiated by me. And the first video which I have shown you of flowering in a greenhouse was made in CSRD. So now many people show in the close this one. So how that is that indoor farming which is developed by nobody has developed, but people are giving the training who are
yes, sir.
not experts in this field. They are not biotechnologists. So that is and because of that greed for making quick money, people are jumping into that. So many people approach me also. I tell them that this is not possible. This is not technology which I have developed. And some people are always when some many such scams happen. So I am not
Yes,
part
sir.
of that. And my work is the scientific work, which has taken a long time. And one by one, I have put all this together. And as it stands, so it is not indoor or there is no chiller or there is no aeroponics. This I told you that saffron is not a crop available for, it's not an easy crop to grow anywhere. It
Yes,
can
sir.
be grown only in specific locations and that need to be identified. And when I was working, I had to study the soil chemistry to a very great extent. Understand?
Yes, sir.
So it's not like only plant tissue culture. I was not sticking to one. So in an academic setting, you can do research in many ways. So some can be curiosity driven basic research, it's research in publication. Some can be some research result in industrial application, which is patented and licensed to the industry.
Yes,
So
sir.
this work was done by me to have some societal benefit to the farmers because I was in biotechnology. I have extended my work to agriculture biotechnology. I understood high value crop and tried to develop a technology and which can help. So I have done almost 80% of the work and some little the field trial, identifying the location and doing a field small trial and giving to the farmers. So then when the farmers grow, I cannot grow and go and grow the
Yes, sir.
crop there.
Definitely.
So the farm belongs to the farmer and he gets a new crop because the climate is suitable and some little modifications will be required. And then once he grows and only one farmer grows in 1 acre, it doesn't work. Then it should result into a something like 500 or 1,000 acre. Then that area become a center of production. Then like other aspects they all come together. Then the traders realize that from this can be one area from where we can procure. So then
Got it.
trade happened. So many farmers they grow and then gradually there, like in how it has happened in Pampur or in Kishtwar, there it was introduced. I told that there are many
Yes, sir.
stories, maybe 2000 years back or 1500 back or sometime. It was introduced there by identifying the local climate and soil are suitable. And that time the technology were not available. Now when since we have technology, we can modify some of the aspects and we cannot introduce everywhere, but the field cultivation through field cultivation is not possible. There in such locations, field cultivation is not
Okay.
possible. It may be requiring, some modification of some of the climate factors
Yes, sir.
and modification of soil, planting medium, and things like that. So it should be always like simple technology. What of farmers is not very high tech.
Yes, sir.
Many of them, what they need is only medium tech or low tech. But it may be a new crop or it may be a new way of growing it, and so that it can increase their profitability, and then that works. So what I talked about indoor saffron farming is a spin-off that is happening in but people are coming back to me and asking question that we are getting only a small quantity. It is not feasible. What to do? I said nothing can be done because it's not my technology. I don't.
Because
I
that
was
data
doing
can
something.
also be
Huh?
manipulated, and it can
Pardon?
be used in illegal form. The data that you have occurred and made, that
Yeah, yeah.
it can be used by other people, like non-professionally also, because you know that saffron is
No, no,
illegally
no.
also sold.
Yeah, yeah. This when it comes to, I don't know the time told it is. Sorry. Huh? Yeah, yeah. Okay, no problem. We can continue for 5 minutes because your mentor. When we talk 4 to 5:30 about 1.5 hour like that. But
Yes,
still, the interesting question is asked. I will continue for some time. And what happens is, I have done research on when you are looking at a crop or a plant, I can look only at tissue culture, but I wanted to look at all aspects. So I have done studies. Some students have approached me. One MTech student came and she wanted to work. I said that I am working on saffron. We will do one thing. I have given another topic, lab based, but it did not work out. So I told that you do a market research on saffron, uh, that what the packing, pricing, the quality. So we have collected all samples and we have found zero point 0.5 gram, 1 gram, 2 gram, 5 gram, 10 gram. And what is the packing? Most common packing is 1 gram, 2 gram. So 300, 400 the pricing. Secondly, we have done the analysis and found that a large number of market samples are adulterated.
yes, sir.
It can be 10% adulteration, it can be 90% adulteration. It can be totally extraneous material. This is something else. They may add color and produce like paper and cut it and produce, or they add that filaments of maca, the maize.
Yes, sir.
You know that what you call that? That maize,
Yes, sir. Gehu.
that filaments.
Got it, sir.
That is content color. Jalebi color is
Powder.
added, dried, and it is added to the saffron, or it is sold as saffron only. So it
Okay.
gives only a color. It is a grade 2 salt or dye, what you are adding. But saffron contains phytochemical which have great, you know, health
Health
benefits,
benefits. Yes, sir.
and it is used as medicine also. For macular degeneration in ophthalmology, it is used. It is found to be very useful. And if you are looking only at the medicinal uses of saffron, it is ever increasing. There is a great demand also. So, like this, what I want to say is that that aspect is not by this one. I told that this is
Yes, sir.
happening. People are calling me and say that no, I have not given you technology. If who are given training to you, you ask them. And if you do not, by calculation, that this much will be the cost and this much will be the outcome. And this indoor farm, saffron cultivation, as it many reels are there, and social media, there is now many reports. It is only a spin-off. I have not given. This is a not a technology which is fully developed, or
Yes, sir.
it is, but it is happening as a like it is going on. And people call me. I say no, it will not work in this area. In indoor, it is not possible. You may not be able to produce the replacement comps there and things like that. And in conclusion, I would like to now the student organizers and other audience, I would like to tell you one thing. It is a great initiative, and People University, Bhopal, and the CSRD, as in you are very fortunate to be there, and under the mentorship of Professor Subhash More. He is a great teacher and a very hardworking person, and I have great long association with him, and I know him as a my junior in the Department of Botany where I did my MSc and PhD. He did his MSc, then he came to NCL, and from that time, maybe 96 or 97 onwards, nearly for 30 years, we have a close association for one reason, that we have common interest. Hmm. And uh, that we keep on discussing like this. So you need a good mentor and great learning outside the classroom and the lab to know the world and talk to experts and exposure to the actual scientists, teachers, or industry persons, so that the biotechnology, as a after the degree you come out, you know that okay, you can identify also what is your potential and what are your aptitudes, what is your interest, so that you can identify your niche area, whether it is research, whether it is teaching, whether it is management, or whether it's policy making. So after biotechnology masters, you can have job in policy making bodies also. So where the jobs are, I think you are getting good training in this university and this department, and wish you all good luck.
Thank you, sir.
And I am really honored and I am happy for talking to the students who are interested, and secondly, talking on a topic which is very close to my heart, that is Saffron. So it was great. Thank you very much, and wish you all the best.
Thank you, sir.
It's our pleasure, sir. Thank you so much. Now it's over to our MC, Miss Preeti.
Thank you, everyone. Now I hope everyone has given their feedbacks. Please note that you will receive your e-certificate shortly. We look forward to seeing you in our next BioConnect session very soon. Until then, stay curious, stay inspired, and keep connecting. This is Preeti Kushwaha signing off on the behalf of the CSRD student team at People's University. Have a wonderful evening.